Hello guys, my name is Yunzhe Chen and this is our machine learning final project distinguish bots from Twitter accounts.
Hi guys, my name is Ming He. Let's move to the overview of problem. There are billions of Twitter accounts on the internet. However, not all the accounts are performed by people. Many accounts are signed up and tweeted by robots. We call them as bots account. Our work is to use the algorithms like random forest and a decision tree to deal with the 19 attributes of the accounts that are collected by the whole class and merged by professor as training data to train the computer to predict whether a Twitter account is bot or not.
And now let's take an overview of raw data. As we can see from the above picture, each account has up to 19 attributes and that show the features of the account and also one attribute that describes whether the account is bot or not. Some of the features are integers, some are characters, some are URLs, and some of them are just true or false, even some of them are null. It is obviously that the raw data cannot be used by us to apply them to any existing machine learning algorithms. So the first step that we have to do is deal with the data.
So let's look at the processed data. We first divided all these features into different kinds. As you can see in the picture, the first is the feature that we will not use, such as ID string, and language. The next is a feature that only have the possible values as true or false, verified, default profile image, and has extended profile. The third is a text feature that may have the word bot, such as screen name, description, status, and name. And the other features that count the information of the account as follow count, friend count, listed count, favorites count, and status count. And next is a feature that may be none, such as location and URL fields. The final is a features that have limited possible values as credit count.
Then we talk about the specific way that we convert the data into the form that we can use, like the features that with true or false. We will convert the true into 1 and false into 0, and also the text data with the word bot, we will convert them into 1 and the others will into 0. And the features that count the information of the count, like follow count, we will convert the count that have less than 10 follow count into 0 and the others into 0, into 1, sorry. And then we look at the model that we used. First, it is Bernoulli naive Bayes. We can see the accuracy is 85%, and here are the ROC and the confusion matrix of the Bernoulli naive Bayes. And now we can see the decision tree. It is a little bit higher than the um, naive Bayes. And now is logistic regression. Although the accuracy is not as high as decision tree, but it performed better than decision tree in the later algorithm voting. And now is random forest and gradient boosting decision tree. They all perform well in all the 3 experiments that we did for the different data set.
The model we used is voting. And finally, we try to use the bagging to improve the performance of our algorithm. We picked 3 algorithms of great performance and let them take the scale of 1 to 2 to 3 for voting. So, for the final training data, we used several algorithms to predict whether a Twitter account is bot or not. The conclusion shows as follows. In In our three experiments on midway datasets, training data and test data, the performance of gradient boosting decision tree is good. And after we have searched for other information, we know that the GBDT algorithm is very outstanding in machine learning algorithm. Voting classifier to the voting another great point that we have learned from this experiment, we find we can always get a better accuracy when we applied voting classifier to the algorithm that performed well in the experiment.
And finally, it is the evaluation of our experiment. We are experienced with Excel, so we can start our data processing when we get the datasets and can immediately find the way to turn the different kinds of raw data into the form of data that we can sufficiently utilize in our algorithms, which can save as much time. And the dataset for midway project, the training data for final project, and the test data are of great difference that confused us a lot. For example, in the midway dataset that collected by the whole class, the attributes like name, screen name, and the description are ignored by us because we can hardly find the rule of these possible values. We can just divide them into now or not now. However, in the final project dataset, especially in the test data, we find that many of the accounts have the word "bot" in name or description, which definitely told us the account is a Twitter or not. Nevertheless, for the value like verified default profile and only have two possible values, true and false, and the status count that have thousands possible values but can divide it into some classes in training data and the midway dataset. Much of this information is known in the test data. This situation that the result of our algorithms we defined by the training data are useless for the test data. 是这样吗？video 是这样拼吗？